So lists and tuples. Some people call them tuples instead of tuples, but either pronunciation is considered acceptable. So let's say you need to do something with a bunch of different values. So, I could say A is 5, and B is 10, and C is 12, is 12, and then I could write expressions for A, and another expression for B, and another expression for C, but that's not very efficient if you need to do the same thing to 5, 10, and 12. So a list is exactly what it sounds like. It's a way of making lists of objects. So I can say A is equal to square brackets, 5, 10, 12, like that. And that creates a single object which contains all of those values in sequential order. Okay? Yeah. So the square brackets say anything inside the square brackets is going to be a list. So the properties of the list, again, are it has order and it has contents. So you can't have sort of missing elements in a list or something like that, although you could put nones in the list if you wanted to say that there's some value that's undefined in the middle. Now, in many programming languages, which have the concept of lists, they're pretty pervasive. It's a pretty pervasive concept, even if it's not built into the language. Usually, there's some library that will support lists. In most languages, lists can only contain values of a particular type. If you make a list of integers, all of the values in the list have to be integers. If you make a list of floating point numbers, they all have to be floating point numbers. If you make a list of strings, they all have to be strings. Python does not care. Python allows you to freely mix whatever you'd like in the list. So I can make a list which is A is equal to 1, 5.3, ABC, and technically I can actually put a list inside a list, like that. Okay, so you can put anything you like in as an element of a list. So lists are actually very similar conceptually to strings, which is something we talked about towards the end of the last module. So a string is more or less just a list of characters. And we talked about using slicing to get at substrings inside strings. Well, you can use exactly the same methodology with lists. So if I want the first element in the list, I just say A square brackets 0. So I just said that you use square brackets to define lists. Well, that's true only if it's on sort of the right-hand side of an expression. If you put square brackets immediately after a variable name, or after a list name, I could put square brackets out here to access the elements in the list, then it's used for accessing elements in the list rather than for defining a list. So you could come up with, for example, a fairly confusing looking thing. If I took that, oops, what did I hit? Oh, there we go. So if I take that and I said square brackets 1 after it, that's going to define the list here, and then this is going to access the element number 1 within the list. Okay, so you can create some things that look kind of funny syntactically until you understand what's going on. So we can access individual elements in the list. If you try to access something, if you try to access something outside the list, past the end of the list, it'll give you an error, as it should. Just like before, you can use A of -1 to get the last element in the list, which is another list. So if you have a list inside a list, you could say something like A of -1 of 1, and then that would give you the list from here, and it would give you the second element in the list from here. You can do slicing just like we saw last time, so we can say A of 1:2, which say 1:3, and that'll give you those two elements in the list. All right, the major difference between lists and strings is that lists are mutable, whereas strings are immutable. What does that mean? So when you define a string, as I said last time, you can't change it. You can make a new string that is similar to the original string, but you can't change the actual string itself. Lists, on the other hand, you can change the elements. So if I say, oops, I didn't mean to put another list in there, I can say A of 3 is equal to 77. And now I've modified the contents of the list. So you can freely change them. If lists have types which can all be compared with each other, so let's say we redefine A to be 1, 5, 3, 7, 2, 6. I can say A, so A is that, and I can say A dot sort, and now A will be a sorted version of the list. And that's the same list. It was sorted in place. It didn't create a new list object. So if I, A itself, the list that A was pointing to is still the same. It didn't change. There is also a reverse operation. And now we have a reversed list. There's also a reverse operation which can be used on strings. But it's not reverse, it's reversed, which we'll see in just a second, because you can't modify strings. So in this case, we were reversing the list in place. If you try to reverse a string, it will yell at you because you're not allowed to change them. We'll get back to that in a second. All right, so let's see. Slicing, we already talked about slicing. Other methods. Right. Other ways of modifying lists. So if we have our existing list and we want to add something to the end of it, there's a method called append, which will allow you to add new elements to the end of the list. If you want to add multiple elements to the list, let's say you have one list and you want to add another list to that, there are two ways. You can return a new list. All right, let's make another list. Let's make B is equal to 5, 3, 1. So we have A, and we have B, and we can say A plus B. That will return a new list, which is a concatenation of the two lists that we used as inputs to plus. You can add a bunch of lists together, but again, that creates a new list. If you want to modify a list in place and add the new elements to it, you can say A.extend B. So instead of append to add a single element, extend allows you to put a list at the end of another list, and now A will contain that much longer list of values. If you need to remove an element from a list, there is this isn't a method, this is a built-in part of the language. You say del A of 3, for example. And now A will be missing the third element from before. That was actually a little tricky, since the third element was actually a 3. That might be confusing. Maybe we should do that one more time. And now look at what we've got. Okay, so it was removing the third element, number 3, from the list. It was not removing the number 3 from the list. Okay, so del remove. So remove does the opposite. Remove allows you to say remove the first instance of a particular element that you find in the list. So that will, if you say remove 3, it'll find the first 3 and take it out of the list. Count, just like the string count, it will tell you how many values of a particular, how many instances of a particular value there were inside the list. Index is like find. So if you say a.index 5, it will tell you that the first 5 in the list was at element number 2. So that's just like find in a string, basically. So we did reverse and sort. Now this is what I was talking about before. Now, I've told you about lists. I haven't told you about tuples. So what is a tuple? So let's say I've got A, which is this. Now I'm going to say A is equal to exactly the same thing that we had here, except I'm putting it inside parentheses instead of square brackets. Looks exactly the same, except there are parentheses instead of square brackets. This is not like the string definition where you could use single quotation marks or double quotation marks. Okay, this is actually a different type of object. The square brackets makes a list. The parentheses make a tuple. A tuple is exactly like a list in every way except it's immutable. Okay, so if I try and say now A of 3 is equal to 5, it will say tuple object type does not support item assignment. You can't modify tuples. Now you would say that seems really stupid. Why would you have a list object which is very flexible and you can do anything you want to, and then have another object which is exactly the same but you can't change it? There's actually a very good reason for that, but we're not ready to get to it yet. So we'll get to that in a little while. But generally, basically speaking, anything you can do with a list, you can do with a tuple as long as it doesn't modify the tuple. Now, what if you have a tuple and you want to sort it? So, in addition to the method sort that exists for list objects, there is a function built into the language called sorted, and another one reversed. So if I say sorted A, that will return a new object which has been sorted. Okay? So we had A, again, A is a tuple, and if I say sorted A, it will return a new list which has been sorted. Similar with reversed. Reversed will reverse whatever the object that you provided is, assuming that the object has a sequence of values in it. All right, and I should also add that like most things in Python, reversed and sorted will work with any sort of object which seems to be a sequence of values. So it'll work with strings too. So if you have a string, you can say reversed string or sorted string, and it will return a sorted version. Now there will be some cases where you get something a little funny. Instead of getting back the actual reversed object or the actual sorted object, you'll get back this thing which looks kind of funny. It's a reversed object. And what this does is, instead of actually creating a new string which is reversed, it creates this object which can return the sequence of values for you in that particular order. So if you had a string which was a billion characters long, and of course that exists if you're doing, say, genome sequencing, something like that. If you have a string that's a billion characters long and you say reversed, rather than creating a new object that's a billion characters long, it creates this special reversed object which allows you to access the values in reversed order. So if you need to explicitly convert this into something that you can work with and modify or something like that, then you can convert it into an object of a different type. And we'll be getting to that very shortly. So I'll just sort of skip the details on that for the moment. So there are other methods of lists. I've just gone over the major ones here. This is a good opportunity to remind you to familiarize yourself with the Python documentation. If we go to python.org, and I had this link in the previous lecture, you'll see there's a documentation link, and we can find, they've rearranged it. There we go. So here's the Python documentation, and if you go to library reference, that will tell you all of this useful stuff about the language itself. So it'll tell you about the built-in types, which we're going over right now. It'll tell you about all of the various modules which are built in, and tell you about all of the different methods that are available for each of the modules. And you can see this is a really long list. All of these modules, so each line on here isn't just a function, it's an entire module containing a whole bunch of functions and methods and classes. So all of these things that we're seeing here are actually built into the Python language itself. So you don't have to install anything extra or anything like that. Anything you see on this page, you'll have with Python on any computer. So if you wanted to find, oops, too close to the edge of the screen. So here, if we go to built-in types, and we go down to sequence types, you'll see in here, this is where it'll define all of the various things that you can do with sequence types. Here are the operations I was telling you about, like append. So there's another one called clear. There's another one called copy. So there's a bunch of methods that we haven't actually discussed explicitly. So it's a good time to sort of get used to starting to work with that documentation. Okay, that's it for lists and tuples.